All right, this is chapter 4 in William Walker Atkinson's The Mystery of Sex or Sex Polarity. Chapter 4 is Sex in Plant Life. To many persons who have not considered this phase of the subject, it may seem strange to hear scientists assert that the manifestations and activities of sex are much in evidence in the world of plant life as among the animals. The male and female elements are found in every plant, and reproduction is the result of sexual union, just as truly as is the case among animals. The flower is the sexual organ, or rather organs of the plant. The female element of the flower produces the seed of the plant, but only when it is fertilized with the sexual product of the male element. In some cases, the male element is found on one plant and the female on another. In other cases, the male and female elements are found in different parts of the same plant, as for instance in the case of the Indian corn, in which the tassel contains the male dement or flowers, while the silk contains the female element or flowers. I guess I was supposed to say the male element or flowers, and the silk contains the female element or flowers. The ear containing the seeds afterwards, emerging from the female element or flower after the latter has been fertilized by the male element. In the greater number of plants, however, the flower contains both the male and female elements and is thus fully hermaphroditic. In order to understand the activities of sex among the plants or flowers, let us consider in detail the several parts of the plant sex organ, which we know by the name of flowers. First, we have the part of the flower known as the calyx, which is the cup of the flower, which covers its lower and outer parts, and which is generally of a green color. Next, we have the corolla, which is the crown of the flower, which is composed of petals, usually beautifully colored, and which to many constitutes the real, quote, flower itself. The calyx and the corolla form a cup-like receptacle in which are found the two essential and distinctive sex organs of the plant: the stamen, or male organ, and the pistil, or female organ. The stamen, or male organ of the flower, is an upright, thread-like filament, bearing at its summit two minute sacs, which are called the anthers, and which contain a very fine, microscopic dust or powder called the pollen, and the latter being the active male element of reproduction. The pistil, or the female organ of the flower, is found in the center of the flower, in the middle of the stamen, and which secretes and stores in a tiny cell the female element of reproduction, which is called ovule. Crowning the pistil are found the style and the stigma. Some flowers have but one stamen, others have two, others still have many. Linnaeus was the first great authority to explain the sex activities of plants. He says, quote, "The flower forms the theater of the amours of the plants. The calyx is to be considered the nuptial bed. The corolla constitutes the curtains." So again, let me read that over. He says the flower forms the theater of the love of the plant, basically, or the desire of the plant. The calyx is to be considered as the nuptial bed, and the corolla constitutes the curtains. The anthers are the testes, the pollen the fertilizing fluid, the stigma of the pistil, the external the external genital aperture, the external genital aperture, the style, the vagina, or the conductor of the prolific seed, the ovary of the plant, the womb, the reciprocal action of the stamens on the pistil, the accessory process of fertilization. Kellogg says in many instances the action of plants seem almost to be promoted by intelligence. At the proper moment, the corolla contracts in such a way as to bring the stamens nearer to the stigma, or in contact with it, so as to produce fundication, or fertilization. In some aquatic plants, the flowers elevate themselves above the surface of the water while the process of fertilization is effected, submerging themselves again immediately afterwards. Others, very curious changes occur in flowers of different species during the reproductive act. The stigma is observed to become moistened and even become slightly odorous. Often, too, it becomes intensely congested with the juices of the plant and sometimes even acquires an uncommon and most remarkable degree of contractility. This is the case with the stigma of the tulip and one variety of the sensitive plant. And in these plants, it is observed to occur not only after the application of the pollen to the stigma, but when excited by any other means of stimulation. The flowers of some plants during and after fundication or fertilization also show an increase of heat, in some cases so marked as to be readily detected with a thermometer. This is said to be especially the case with the arum of Italy. In some plants in which the pistil is longer than the stamens, thus elevating the stigma above the anthers, the female organ is often observed to bend over and depress itself so as to come within reach of the anthers. Fertilization of the female elements by the pollen of the male element in plant life is effected in numerous and various ways. In instances in which the male and female organs are situated on different plants, as in the case of the willows and so on, the pollen is carried to the female flower by the passing breezes, the transfer often being effected over great distances. But the more frequent method, and the one in operation where the male and female elements are near each other, is that of fertilization by the means of insects, small birds, and even animals like the snail. Sprengel was one of the first naturalists to discover and announce this, quote, secret of nature, unquote. He anticipated the latter researches of Darwin, and indeed cleared a path for the later scientists. As Getty says, quote, Sprengel laid the sure foundation, now somewhat hidden by the superstructures which Darwin and others have built. To Sprengel's eyes, the many ways in which the nectar is protected from rain seems full of intention. He recognized in the markings of the petals illumined finger posts to lead insects. Let me read that again. He recognized in the markings of the petals illumined finger posts to lead insects to the hidden hoards. And he further demonstrated that in some bisexual flowers, it was physically impossible for the pollen from the stamens to pass to the tip of the carpels. His general conclusion, freely stated, was that since a large number of flowers have the sexes separate, and probably at least as many hermaphrodites have the stamens and carpels ripening at different times, nature appears to have designed that no flower shall be fertilized by its own pollen. A few years later, In 1799, Andrew Knight maintained that no hermaphrodite flower fertilizes itself for a perpetuity of generation. Sprengel's Secret of Nature had, however, to be set afresh by Darwin, who in his Fertilization of Orchids in 1862 and Effects of Cross and Self-Fertilization in 1876 has not only shown with great wealth of illustration the manifold devices for ensuring that insects unconsciously carry the fertilizing pollen from one flower to another, but has also emphasized the advantage of cross-fertilization for the health of the species. Nature tells us, he says, the most emphatic manner that she abhors perpetual self-fertilization. Hildebrand, Hermann, Müller, Delpino, and others have, with consummate patience of observation, further traced out the secrets of nature in this relation. And the student may be referred to G. R. Thompson's valuable edition of Müller's Fertilization of Flowers. Sir John Lubbock's Flowers in Relation to Insects, the classic works of Darwin, and P. Coase's Handbook, second volumes, in 1892, reference must, however, also be made to Meehan's protest that self-fertilization is neither so rare nor so abhorrent as is generally believed. In a great number of cases, cross-fertilization by means of insects does occur. In many, it must occur. In another by no means small set of flowering plants, usually with inconspicuous blossoms, the fertilizing gold dust is borne by the wind and falls, like the golden shower of Danae, upon adjacent flowers. In many hermaphrodite flowers, again, self-fertilization does certainly take place. In some, this is necessarily so. Indubitable self-fertilization occurs in the small degeneration unopening. Self-fertilization occurs in the small degenerate unopening flowers of some plants, such as the species of balsam, dead nettle, and pansy, and so on. These occur along with ordinary flowers and, curiously enough, are sometimes more fertile than they. Another authority says, quote, fertilization is the fundication of a plant by the application of pollen to the stigma. In some cases, the pollen simply drops upon the stigma, which is called self-fertilization. In most instances, however, it is blown by the wind, or carried by bees or moths or such like insect from other flowers of the same species. This is what is called cross-fertilization. Darwin found that 20 heads of Dutch clover left open to the visits of bees produced 2,290 seeds. The same number defended from the visit of bees did not yield even one seed. Plant life affords many curious and interesting instances of ingenious devices arranged by nature for attracting to the flower the insects needed to fertilize it. The bright colors of the flowers and the honey or sweet fluids contained within many flowers being intended solely for this purpose. The shape, the size, and the various parts of the flowers are arranged so as to cause the bee or other insect first to brush against the receptacle containing the pollen, and then to brush the same off unto the female parts of other flowers. The subject is extremely interesting and will well repay one for studying it in detail in the textbooks on the subject. That is the end of chapter 4. Chapter 5 will be sex in animal life.